Morning all. Now I'm just looking at the Arduino PWM solar charge controller again, and I've got battery, 40 watt bulb as a load, got the scope, and we've got potentially a few minutes of blue sky before all that horrible grey cloud comes over, so I might be able to do a few tests. So not enough sun to get pulse width modulation with the light bulb on, but what I'm really interested in is how rapidly this responds to having the load removed. So let's just bring that within range, switch that off, and it responds quite quickly, and this is because the software now has some proportionality added into it so that it can move quickly when there are large changes. The lamp's back on now, so that's gone to a full 100% PWM because the solar panel can't actually cope with this 40 watt lamp. 80 watt solar panel, 40 watt incandescent bulb on a inverter there, but scope switched itself off. It can't quite generate enough power to overcome that 40 watt load. Let's try again. Right, now we do have enough sun. So with the load on, 40 watt load, there's a lot of jitter on that. Let me just bring it down into range of the trigger. But what have we got? About 75% PWM. Now let's switch off the load, and it rapidly drops to no PWM to compensate for the fact that the battery voltage rises up, and then settles at 5 or 10% PWM to maintain the battery voltage with no load. Let's have a look at the overshoot on the digital meter. Switch the lamp on. Okay, the lamp's on. That's pulling the battery voltage down a bit, and that's probably because of resistance in these black and red wires, so that we're getting a slightly lower voltage visible on the controller. Or would it be lower or higher? Anyway, that's what's causing that. Now let's look at the overshoot. Switch the bulb off. So it only shot up to 6.3 and then settles back at 6.0. So I think that's solved the overshoot problem, even if some problems still remain. So I'm having to work quickly because we haven't got much of this blue left, and then it's all grey over there. So high PWM there. The solar panel's just about keeping up with the load to hold the battery voltage constant. That's good, but lots of jitter. Notice that the jitter is large amounts of jitter, and I suspect that this has something to do with the asynchronous reading of battery voltage, the asynchronous analog to digital reads not being synchronized with the pulse width modulation frequency itself. Now on the PWM5 I was able to synchronize those because there was an interrupt source from the PWM hardware, and I was able to use that to trigger the ADC reads. So it would read in the same place in the PWM cycle. So for example, you've got this nice stable rising edge here. If you take a read just a fraction of a second after that, then you'd get synchronization between the reads and the pulses, and that helped prevent this jitter. Because what's happening here is that when it reads, it sometimes reads when the pulse is high, it sometimes reads when the pulse is low, and those two reads will be different values because of the current flowing in those red and black wires, and I think that's where some of this jitter is coming from. Now it's holding up pretty well now. The sun's quite strong, and it's able to cope with this 40 watt load. Here's my 40 watt bulb burning brightly, and the panel is able to drive that and keep the battery charged at the same time. Now with regard to this jitter, it may be because of the limited range of interrupt sources on the Arduino that there's not a huge amount can be done about this. I mean, I will look into damping it down a little bit. But one thing I've eliminated and I'm happy with now is the overshoot. If I switch the load off, let's get my hand on the inverter, it very, very rapidly goes to a low value of PWM, so we're going to get very little overshoot on battery voltage now, and that was something that was concerning me because the battery voltage could shoot up quite high when this PWM was sort of tracking it slowly back, because it took 2.5 seconds to go from full PWM to 0 PWM when I was stepping it a single step at a time. Now I'm allowing it to take much larger leaps when the target voltage is some distance away from the measured voltage. So voltage regulation is good. You can see the jitter there, but a few tens of millivolts of jitter may not necessarily be a major problem. Obviously pulse width modulation, feedback control is working fine, so I think I might actually say that this is version 1 now. I might try and get this up on GitHub as version 1 and concentrate my efforts now on building hardware for the Pro Mini. So initially a piece of stripboard that sits behind the Pro Mini with the components on, and then possibly even design a printed circuit board, possibly if I can get it small enough, the same size as the Pro Mini, so they can just be sandwiched together to create this this unit. So it's getting a bit cloudy now. There's a little bit of blue there, but then after that it's very much grey. It seems that ever since Hurricane Bertha came over from the USA, we've had the most atrocious weather, mostly rainy. It is at least dry today. So I think that's version 1 of Arduino PWM, or whatever I'm going to call it, in the bag. I'll have to learn GitHub now, which I've been putting off. Weather's absolutely confounding me. It's just enough sun to keep the battery voltage up with the 40-watt bulb. Just some hazy sun up there. Now, apparently the next hurricane after Bertha, so a name beginning with C, I can't remember what it is now, but that's coming over. But apparently it's going to track ever so slightly further north and then suck warm, hot air up from Spain. So we're promised a few nice, warm, sunny days. Lovely!